Good afternoon, dear student. Today we have started the remaining topic of our first lecture, that is the Indian remote sensing satellite and the other remote sensing satellite. Today we have cover the Spot, ERS and QuickBird remote sensing satellite. Let's see the one by one of that remote sensing satellite. Okay. So first we have seen the Spot series of satellite. I have already told you the Indian remote sensing satellite is launched by Indian Space Research Organization. Likewise, the Spot series of satellite is related to French government. That is the French government has started the program for the development of pole observation spot program. Okay, designed in the designed by the French Central National Satellite, that is CNES. Okay, you have to just remember this spot series of satellite is governed by the French government. Okay, which includes the development of large-scale international program with ground receiving station and data distribution outlet located in more than 30 countries. It means this spot satellite having working in more than 30 countries. It having the side of side nether viewing capability and afford full screen stereographic imaging from two different satellite tracks, permitting coverage of the same area. Okay, then in this spot satellite of series we have four spot type of satellite, that is spot 1, spot 2, spot 3 and spot 4. Okay, the spot 1 series having launch on December 31, 1990, and spot 2 series launch on January 21, 1990, spot 3 series launch on September 25, 1993, and spot 4 launch on 26 March 1998. Spot 1, 2 and 3 have identical orbit and sensor system. Okay, I have already told you the every satellite had which having the identical orbit and identical sensor. In this spot series of satellite, it is spot 1, 2 and 3 have identical orbit and sensor system. Okay, you have to just remember this spot series of satellite which is governed by the French government, and the agency is French Central National Itudes Spatials, that is CNES. Okay, then next, that is the sum of the introductory for parts. That spot 4 includes the additional 20-meter resolution bands in the mid-infrared portion of the spectrum between 1.58 and 1.75 mm. Okay, this band is intended to improve the vegetation monitoring. This spot 4 especially working vegetation monitoring, mineral discriminating capability of the data. Then furthermore, this mix, that is 20 m and 10 m data set will be co-registered on board instead of during ground processing. It means at the time of the that is the working of that particular satellite, which having the resolution 20 mm and 10 mm, that is mixed. This will be accompanied by reflection panchromatic band spot 1, 2, 3 and 0.49 and 0.73 with red bands from this system. Okay. Then next, this band will be used to produce both 10-meter black and white images and 20-meter multispectral data. Another change in spot 4 addition to separate wide field of view sensor called vegetation. It means that is spot 4 data is mostly used for the vegetation monitoring and mineral discriminating. Okay, then spot 5, that is the another one. I have told you spot 1, 2, 3, 4. Then another is spot 5 is the latest in France series of Earth observation satellite. All these are orbit by Earth spin. Since the first spot satellite was launched in 1968, the spot system has brought to provide the continuity of service, constantly improve the quality of product for users. That is the mostly that is the in the form of your vegetation monitoring and mineral discriminating. Means in spot series we have 5 types of series, that is series satellite spot 1, 2, 3, 4 and 5. Mostly this improves the vegetation monitoring and mineral discrimination capability of that particular data. The spot 5 is the latest in the Earth observation satellite system. Okay. Then this is the table which show the name, launch, sensor, bands, spectral range, resolution, swath and revisit. Means in revisit means days, that is the here you can see spot 1, 2, 3, 4 and 5. Here it is launching date, here it is 26 is the revisit time. Okay, and swath is 60, resolution 10 meter to 20 meter. I have already told you the resolution is same, that is 1 in spot 1, spot 2, 3 and 4 resolution is same, that is 10 to 20 on, and bands are made somewhat different. Okay, and revisit time, that is the which means just like in geostationary study, that is the 24 hours revisit time. In the particular, that is the 26 days. Okay, this is the revisit time in spot 1, 2, 3, 4. You can just remember this type of table, then easily you can understand the which type of spot 1, 2, 3, 4, and which particular days. That is, you have just remember this is only for the vegetation monitoring and mineral discrimination. Okay. Then next, that is the this spot suddenly having three types of bands. In that particular band, we can see one by one. That is band one, green band, which having the wavelength range 0.50 to 0.59 micrometer, recommended for use in combination with other band because of low contrast and sensitivity to haze. Haze means snow. Okay. Base for showing roads and bare soil. That is resolution 20 meter. I have already told you there is a common resolution in that particular spot 1, 2, 3, 4. That is 10 meter to 20 meter. Okay. In that this band one green shows for road and bare soil, and you have to remember the wavelength range, that is 0.50 to 0.59 meter. Then next is band 2, that is red. It is having wavelength range 0.61 to 0.16 meter, and this shows the contrast between vegetated and non-vegetated area. If if in exam the question is asked, that is the write the details of spot series of satellite, you have to know the, you have to focus on this, that is the bands shows the vegetated and non-vegetated area. Okay. Then third, that is band 3, that is near infrared data. Then wavelength range having 0.79 to 0.89 micrometer. This band is used to evaluate vegetation, biomass, and separate water from the vegetation. Okay, this is the three types of bands is used for that particular spot series of satellite. Okay, that is band 1 green, band 2 red, and band 3 is near infrared. This is the all about the uh, spot satellite. And which type of instrument is used in spot, that is HRV, high resolution visual imaging instrument. Okay, the HRV instrument is the multispectral radiometer designed for the spot spacecraft, which having specially used for this particular spot spacecraft. The HRV instrument provides for high resolution imaging in the visible and near infrared portion. One thing is remember, here is the range, that is the visible to near infrared. You can draw a table in that particular for spot 1 visible to near infrared for the remaining point of. Okay, visible and near infrared portion of the electromagnetic spectrum. The first three spot satellites carry twin HRV that operates in number of viewing configuration and different spectral mode. First three means spot 1, spot 2, and spot 3. That is the operating number of viewing configuration, and you have to remember that is visible to near infrared portion in that particular. And instrument is HRV instrument, that is the high resolution visible imaging instrument, which is using the spot, that is the which is specially designed for this spot aircraft spot um, aircraft. Okay, okay. Some of those viewing configuration and spectral modes include only one HRV operating in dual spectral mode, that is the in both panchromatic mode and multispectral mode, and two HRV operating in the twin viewing configuration, that is the one HRV panchromatic mode and one HRV in multispectral mode. Okay, that is the twin section of that particular aircraft is having the panchromatic and multispectral mode. Okay, and third one is, and two HRV operating independently each other, that is not in twin viewing configuration. If spot is we have to write about the spot, that you have to remember spot 1, 2, 3, 4, and that is the wavelength is near infrared to infrared, and three types of band: band 1 green, band 2 red, and third is near infrared. And resolution is almost same, that is the 10 meter to 20 meter. That is the, I have shown you the table, this table. This, okay. See, is the resolution 10, 20, 10, 20, 20, 10 to 20 meter, and revisit time is 26 days. And here is, you have to remember resolution, bands, revisit time, and swap. Okay. We can focus on that particular and write about the three types of band. An instrument is HRV type of instrument is used, having the some of the in first one, spot 1, spot 2, and spot 3 use, that is the HRV mode. Okay, Then receiving station, as we know, the Indian Space Research Organization having the different receiving station. For that spot having the different location, the two main stations are located in France and Corona, Sweden. These stations are capable of receiving the telemetry recording on board recorders or directly within their visibility circle of approximately 2500 km radius center on the station. That is the 22 direct receiving locations can only receive telemetry within their visibility circle. These are the, you have to just know the name, that is the Toulouse in France and Kiro in Sweden. This is the two major stations which have this particular data collected and proceed for the further processes. Okay. The next is QuickBird. This is the another Indian remote sensing. This is the another world remote sensing satellite having high resolution commercial Earth observation satellite owned by Digital Globe. You have to remember this name, that is it is owned by Digital Globe and it launched in 2001 and recenter after orbit decaying 2015. That is it is Ball Aerospace Global Imagery System. You have to know this name, that is the Global sorry, Ball Aerospace Global Imaging System 2000 BGIS. Okay. The satellite collected panoramic black and white imagery of 61 centimeter resolution. Here, that is the resolution is 61 centimeter and multispectral imagery at 2.44, that is 450 kilometer to 1.60 kilometer means 300 kilometer resolution. You know, you have to remember that is the it is owned by Digital Globe satellite and launched in 2001 and 2002. Okay. This is the image of that particular QuickBird. It is high resolution satellite owned by and operated by Digital Globe. I have already told you this is the type of antenna and this type of having arrangement in that particular QuickBird satellite. Okay. Then what is it? Means which type of work is done in that particular area. That is the imaging satellite owned by, I have already told you, owned by the Digital Globe. Commercially available, collects over 75 million square kilometers of the imaginary data annually. It having the range of that means having the data collection range is 75 million square kilometers. You know, you have to remember imaging satellite and owned by Digital Globe and it is commercially available. And this is the range, that is the 75 million square kilometers of imaginary data annually. You have to remember this. What kind of data is collected? That is highly accurate, high resolution quality. I have already told you this is the high resolution satellite. It's highly accurate, high resolution quality imagery of Earth. That is the quality work has been done here. Okay. Then multispectral and panchromatic use of many applications from map propagation to land management. Application that is the for the land management and map propagation. So to remember that is the high accurate and high resolution quality imagery work. In sensor resolution, you have to remember sensor resolution. I already told you the panchromatic and multispectral. 61 cm GSD, that is the ground sample distance. Black and white 450 to 950 nanometer, 11 bit range. Okay, this is panchromatic and this is multispectral means 2.41 meter GSD at Nadir means equator. Then blue, green, red. Here these are the range of that particular blue, green, red, and near it. Okay, you have to remember that is a panchromatic multispectral and which is highly accurate imaging satellite. Okay, then fact, which type of facts about that particular sensor? That is the launched by Russians in December 1997, and then October 2001 that is successfully placed into the orbit with the capability of 61 meter spatial resolution. I have already told you there is a range of 61 meter and 4 bands blue, green, red, near in front. As compared to spot, there are 3 only green, red, and NR. Here it is the addition of one, that is the 4 bands blue, green, red, and NR. That is spectral resolution. Both spatial and spectral resolution are much improved for the early bird sensor. Temporal resolution of the picture is 1 to 4 days depending upon the latitude. That is the here it is the working day working time is 1 to 4 days as compared to the spot. Spot having the working uh, days is spot 1, 2, 3 were having working days 26 days as compared to this. If you have to compare the big bird and spot, you have to remember this working days of. satellite is the QuickBird. Okay. Then orbit, altitude 450 km, revisit frequency. I have already told you 1 to 4 day, that is the 1 to 3.4 day, depending upon the latitude, and collection per orbit 128 gigabyte about the 57 single area. This is the important points of that orbit. Then what are the different products in which area this QuickBird satellite is working? That is the topographic mapping, land use land cover, crisis management, natural hazard monitoring, and coastal management. These two are the more important nowadays. That is the natural hazard monitoring and coastal management. That is, I have already told you, this is the high accurate, high quality imaging satellite, which includes the working on topographic mapping, land use, crisis management, natural hazard monitoring, and coastal management. Okay. Then this is the one of the picture of that is the sample picture of QuickBird. Okay, this country, China, city, area, sensor, QuickBird, you can see, then acquisition data, date, and resolution. That is the I have already told you 0.620, which is this is the QuickBird, one of the that you can see the area having different houses. Clearly see that the river, roads, and this is the small roads, and this is the different ground area. That is the clearly signals. Imagine quality is very good as compared to other. Okay, this is the another sample area, which I think this is from Egypt. Okay, this is the pyramid. Clearly seen the pyramid. This is the vegetation area. This is the building area. This is the another road. Means from that this is the high accurate and high quality image we can see from that QuickBird software. Okay. The application of QuickBird software, that is in the mining. In mining, we can plan the mining operation. In oil and gas, then utility, then insurance, humanitarian, architecture, engineering and construction, and entertainment. In architecture and engineering construction, for construction of engineering work, that is for example dam, tunnel, with the help of this we can draw the particular image of that for when we have select the particular area for construction of any engineering structure. Before that we have used this particular QuickBird. Then and then we can decide the which type of area we have to choose for that particular engineering construction or architecture. Okay, that is the this in mining, oil and gas, utility, insurance. These are the applications of QuickBird. Mostly architect, engineering, and construction. This that is the what's sensing image are included in that architecture and construction area. Okay. Then another one is ERS, European Remote Sensing Satellite. ERS was the first environmental remote monitoring satellite developed by ESA. Okay. The first thing is, remember that I have already told you that every satellite has its different working principle. For that, ERS is satellite. ERS what is working for environmental monitoring satellite development. It is the mission is detected land and ocean surface change and provide observation data of ocean, polarized vegetation, geology, ecology, and ecology. Okay. This is the working principle of that particular this is the table. So, mission type, agency, European Space Agency. This means ESA, European Space Agency. Mission status, mission completed, launch date, end of life date, and measurement domain. Means atmosphere, gravity, magnetic field, ocean, land, snow and ice. Measurement category. That is, this is the category of this particular E European Space Remote Sensing Satellite. That is multi-spectral engineering, ocean, geology, spectrum, ice. It is the number of. Mostly measurement domain is atmosphere, gravity, magnetic field, ocean, land. If in exam question you have to focus on that. You have to remember the 5 to 10 names. That is atmosphere, gravity, magnetic field, ocean, land, snow, and ice. And the category measurement, that is surface temperature, liquid water, and precipitation rate, soil moisture, surface temperature, land, topography, means sea cover, thickness, gravity, magnetic, geodynamic measurement. Okay. Then this is the detail of that particular measurement detail, that is wind vector, sea level, land surface, vegetation type. Every time there is a repetition of vegetation. Spot one we have also, then in QuickBird we have also vegetation. Then atmospheric temperature, ocean imagery, water leveling, aerosol absorption, obstacle depth, soil moisture and surface domain, then ocean dynamics, topography, bathymetry, significant wave height. These are the measurement. An instrument, that is the ERS, NWR, AMI, RA, ATSR, SAR. These are the instrument. An instrument type, that is this datometers, imaging multispectral radiometers, communications, imaging multispectral radiometers. You have to remember this instrument and instrument type in that particular ERS. This is the picture of that particular ERS. Having antenna, this is the principal surface where this particular image is captured. Then mission capability, which include the AMI, means active microwave instrument, radar altimeter, along track scanning radiometer and microwave sounder and laser photoreflector, and precise range and range rate equipment (PRA). On that particular, this with the help of this with the help of this particular ERS is working. AMI was dual radar which utilized three modes of detect different phenomenon: Earth, then imaging mode, wave mode, and wave scatometer mode. Okay, this you have to remember: AMI, RA1, AS, ETSR, and LRR, PRP. RA1 includes the bands with two modes, ocean and ice, which provide the various ice parameters. Here it is the different use, that is RA1 is used for ocean and tides, having wave height, ocean surface elevation, tide and current studies, and ocean surface wind speed. And ATSR consists of two radiometer, that is micro and infrared, with the measuring of global sea surface temperature for climate change. And LRR, which is used to ensure the accuracy of satellite tracking from the ground. Then PRARE, which includes the data collection from the ocean circulation studies and sea surface topography, was accurate. Means with the help of this RA1, ATSR1, LRR, and PRA, which include the ocean tide and global sea surface and sea surface topography, means that is the domain of that particular, means measurement domain include this RA1, ATSR, LRR, and PRA. This is the illustration of ERS-1 space aircraft. Here you can see the SAR antenna, radar altimeter antenna, attention, PRARE, which then platform, along test scanner radiometer, ATSR, solar array, with the help of wind scatometer antennas. This is the this is the main, that is the platform on this particular this instrument is put, that is the PRARE, IDHE antenna, radar altimeter antenna, SAR antenna, wind scatometer. That is the having the different use. This is the that is the ideal picture of this particular ERS satellite. ERS-1, that is the Indian Remote Sensing Satellite 1, with the Earth means application, that is the overall to environmental monitoring, in particular Microsoft spectrum, that is the regular monitoring land surface and ocean surface process for the change detection, that is the observation of oceans, polar ice, land geology, ecology, forestry, wave phenomenon, bathymetry, atmospheric physics, meteorology. Then scientific research, PIPOR, that is a program for International Polar Ocean Research, PISP, Polar Ice Sheet Program, demonstration of concept and technology for space and ground segment. You have to remember, ERS is working for the mostly environmental monitoring. Besides of that, that is the observation of oceans, polar ice, land ecology, geology, forestry, wave phenomenon, and bathymetry, atmospheric phenomenon, and meteorology. Okay. This is the application of that. Then let's see the celebrating the 30 years of ERS. This is the satellite when what when, that is the when this particular satellite is launched. That is the here it is the time there. Sorry, day and time, that is 21 April 1994 in Ariane 4 rocket from European Spectre 404. French Guiana with the same Sun synchronous polar orbit at 780 kilometer altitude. Then what? What is means observation, that is the ERS and ERS application. I have already told you in which particular domain they hover. An instrument type, that is the SAR, ETSR, GOM. This is the instrument. Data uses, that is the over 500 projects have completed with the help of this. Then invention, it is implemented following the launch of ERS2, which share the same orbit ERS1, that accurate three-dimensional digital map. And heritage value, that is the satellite for exceed their design 3 years, that is ERS1 ending in 2000 and ERS2 in 2011. Today, data are accessible and enhanced in part of heritage space program together what from the other mission, and built by, that is the DSS, Dormant Satellite Surveillance System, GmbH, and data uses over 5,000 projects. You have to remember when it was starting, what the working is done, in which domain, the particular application, that is the in ecology, geology, environmental monitoring, and instrument on which instrument is based, that is SCRRA. This is the best picture, that in one whole picture you have to conclude, that means what, when, application, instrument, build by, and which type of invention is carried out in that particular uh, area, that is the remote sensing satellite. This is the all about the spot, then QuickBird and ERS. Spot remote sensing satellite having the uh, satellite series of spot 1 to 5, spot 1, spot 2, spot 3, spot 4, and spot 5. Then QuickBird is having the high quality imagery system. Then this is the all about the ERS type, ERS1 or ERS2, that is European Remote Sensing Satellite, which having agents under the agency of European Satellite Agency, having mission completed. And this is the measurement category, and this is the measurement, no, sorry, this is the measurement detail, and instrument type, and instrument, which type of instrument, measurement data, in which sector this particular uh, is working. Okay, today we have completed the spot 1, then QuickBird, and um, spot 1, QuickBird, and third, that is the ERS type of satellite. You have to just remember the orbit, which orbit is working, then altitude, for what it is used, that is in which particular measurement domain is used. QuickBird is owned by Digital Global, and it is collected by panchromatic image, that is 61 centimeter resolution. For as compared to spot 1 and spot 2, this having 61 centimeter resolution. Okay. This is the instrument used in spot 1, and that is the bands, green, red, and infrared. This is the type of bands. And this table, that is the most important. You can remember all this. That is the similarity in between spot 1 to 4 instead of spot 5. That is this 26 days is the revisiting time. Okay, this is the best spot series of satellites introduced by French government. This is all about spot 1, spot 2, spot 3, spot 4, spot 5, then QuickBird, and last one is ERS. I have already uh, told the applications and in which particular domain is working. This is the uh, this is the all over today. Okay, so thank you once again for this. Okay.